Hey folks, 6th of April, let's go. So, starting off with a perimeter of a shape. So you have to break it down into all of the components of the shape. We have the quarter of a circumference, so a quarter times pi times d. The diameter is 6 because the whole circle would extend out to this sort of area, except not look like that. But you'd have double the radius, obviously, and then add on the 3 sides, and you've got 10.7 for your final answer. Cool. Second question, if you want to get an expected frequency, which is what this is about, you multiply the number of trials by the probability of success. And that'll give you the expected frequency. Or you could think about it as 35% of 500. Simplifying, add the numbers on the top, and then it's a division, so we subtract 11 minus 3 is 8. Volume of a cone is 1/3 times base area times height. True for a pyramid as well. The base area is a circle, so it's pi r squared. Radius is 4, height is 9, 150.8 centimeters cubed. And this one is about giving an error interval, so this is where we use the whole HAT thing. We want to halve, add, and take away. If it says it's been rounded to 1 decimal place, that means that we've rounded to the nearest 0.1. So that's what we want to halve, and then we'll just add it, take it away. It's important that this inequality sign is less than or equal to, because exactly 0.5 would round up, and this is just up to and including. So because 3.65 itself would go to 3.7. Direct proportion, that means a grid with 2 columns in it. Y and the cube root of x is what we've got here, so we'll write those in on the top, and then we'll put 100 for y and 5 for the cube root of x, because that is the cube root of 125. Then says we want to find y when x is 27, so we want to cube root 27, that'll be 3, and then work out that to multiply across is times by 20, so we'll do that to the bottom as well. You could have done that, I suppose, to get from 5 to 3 is times by 0.6 and done the same thing. If you were asked to give this as a formula, which you're not in this question, we would want to be saying that y is equal to 20 times the cube root of x, because that's how we get y, or realistically we wouldn't want to write the times symbol in there, just 20 cube root of x. Vector BA, so we go from B to O, so that'd be minus A to A, that's plus 2B. This is a sine rule question because there are 2 sides and 2 angles. Cosine rule would be if there were 3 sides and 1 angle. So y over sine 70 is 8 over sine 80. Remember that sides always go opposite the angles they're attached to. So we could think about this as side A, angle A, side B, angle B. And then the way we set it out, we multiply across by that sine 70, we'll get 7.63. Perpendicular means we want to use the negative reciprocal gradient. So we look at this line, it's got a gradient of 4, so our negative reciprocal of that would be minus a quarter. Goes through the point 7.3, so that's our x1, y1. And then we want to use our formula, which we should know, y minus y1 is mx minus x1. Sub all that stuff in, rearrange it, you got minus a quarter x plus 19 over 4, or we could say minus 0.25x plus 4.75 if you wanted. Okay, and then finally we've got the exact value, so this is a non-calculator question, and this is the table of things that we should know. Remember that the general way of remembering this is we need to learn the sine values. They go from 0 to 1, and then it's 1 over 2, 2 over 2, 3 over 2 with square roots. Cos is just the same numbers in reverse, so starts at 1, ends at 0. And tan is sine divided by cos. So 0 divided by 1 is 0, 1 divided by root 3, root 2 divided by root 2, root 3 divided by 1, and 1 divided by 0 doesn't work. So in this particular case, the two ones that we're after are sine 45, which is root 2 over 2, and cos 30, which is root 3 over 2. Add them together. They've got a common denominator already, so just combine the numerators, root 2 plus root 3 over 2. Cool. Okay, then we on to higher plus. So show that. Generally, any sort of situation where it's show that, we want to simplify and expand, or expand and simplify whatever is given, and try and make it look like the thing that we're trying to get it. So I expanded n plus 5 all squared, which is n squared plus 10n plus 25. I expanded n minus 5 squared, which is n squared minus 10n plus 25, and then I subtracted it away. So n squared take away n squared is 0, 10n take away minus 10n, that ends up being plus, ends up being 20n, 25 minus 25 is 0, so we end up with just 20n. Now, show this is positive for all positive values of n. Well, if n is positive, then 20 times n is also positive. Done. A little bit of a harder vector question here. We got quite a lot of bits of information, so let's talk through the order that we did here. Let's switch to green. I think I've used a lot of red. So I got told OA was 3A, that's already on the diagram. OB is 4B, that's already on the diagram. And then PC is 1.5 of OA. So if we multiply OA, which is 3A, by that, we get 4.5A, and we can add that onto our diagram going from P to C. So we've used all those three bits to fill in the diagram. Then tells us that P is a point on A to B such that this is in the ratio 3 to 1. So if we think about that being 4 parts in total, AP is 3/4 of AB, and PB would be a quarter of AB. Use that. Okay, so then find the vector OC in terms of A and B. So to get from O to C, we're going to go from O to A, which we know. We're going to go to A to P that we don't know, and then we're going to go from P to C, which we do know. So it's 7.5A plus this. So we need to work out AP. We know that AP is 3/4 of AB, and we know that AB is minus 3A plus 4B, because we have to go around to get there. So we'd work out 3/4 of that, and then we could label that on our diagram, I suppose. We could say this is minus 2.25A plus 3B, if we go in that direction. And then we can add all those things together. So 3A plus what we just came up with for AP plus 4.5A gives us our final answer of 5.25A, or 21 over 4, I suppose, plus 3B. Okay. And then this question I thought was tough. So let's talk through it. Frustum in general is what you get if you cut the top off a cone or a pyramid. And it wants the surface area of this frustum. How do we do that? Well, I did red first. So first thing I know, and this gets given to you in the exam to be fair, is that the curved surface area of a cone is pi RL. So that means if you've got a cone, then this bit, so not the bottom as well, but this bit its own, is pi RL, when L is like the length of the diagonal and R is the radius. So, okay. So I could sort of figure out what was the curved surface area of the big cone, so all of this, and then take away the curved surface area of the little cone that was cut off the top, and I'll end up with this area going around the frustum. However, I still needed to do a few bits and pieces to do that. I mean, I didn't know L, and I didn't know some other bits and pieces, so I needed to think, okay, well, let's look at radiuses here. The big cone has a radius of 15. The little cone has a radius of 5. So the little cone is a third the size of the big cone. So if the big cone was 21 centimeters tall, the little cone is 7 centimeters tall, because it's a third of that. Okay, so done that. Then, because I don't need the height for the surface area, I need the diagonal, I needed to use some Pythagoras. So I drew a little cross-section of the little cone and the big cone. Little cone, height of 7, radius of 5. Big cone, height of 21, radius of 15. And you can use Pythagoras to work out the side of the diagonal. L squared is 7 squared and 5 squared. So we got that it was 8.6 for the little cone and 25.8 for the big cone. I guess you could have worked out one of those and then divided or times it by 3 to get the other. Anyway, so we've done that. Then we need to put this all together. So what I want to do for this lampshade bit is I want the big surface area of the cone, the small surface area of the cone, and the difference between them will give me this bit going around the outside of the frustum. So pi RL minus pi RL gives me 1080.7 for that. But I also need the circle on top, so that's pi times 5 squared, and the circle on the bottom, that's pi times 15 squared. And if I put all of them together, I get my final answer of something that rounds to 1866 centimeters squared. As I say, quite tough, that one. Okay. And then finally, this is kind of a stratified sample question from the olden days, but it's more of a proportions thing. So we want to estimate how many woodlice live in a greenhouse. We catch and mark 20 of them, return them to the greenhouse, and then catch another 50. And 11 of them are marked. How many woodlice are in the greenhouse? Well, what you've established, or what you can roughly say, is that during your first marking, you marked 11/50ths of the woodlice, or 22% of the woodlice. So those 20 that you marked represent 22% of the total, and then we can work backwards from there, and we can divide by 22 to get ourselves to say that, well, 1% of all the woodlice must be 0.9 of them, and so times by 100 will give us 100% is 91, or 90, I would accept, lice in total. So it's a reverse percentages question, just very carefully cloaked. Okay, folks, hope that helped. Higher plus particularly was tricky this week, this day. I'll see you tomorrow. Cheers.